All right, welcome to the Honors Algebra 2, Chapter 7 video. Today we'll be discussing getting ready for our test on Chapter 7, Rational Expressions. Well, the first thing we're going to talk about is actually direct and inverse variations. If you have a direct variation, y is equal to kx, or dividing the two. Okay, so y divided by x. So if you have the variables divided by, that would be considered a direct variation. Opposite, x times y equals k, or y is equal to k over x, that would be considered an inverse variation. So multiplying the two together, and then obviously neither is neither one of those. So in the first one here, that is actually a direct variation. Okay, because again, if you wanted to solve it for the k value, you'd have y over x equals k. The second one is multiplying, so that is an inverse variation. And the last one is actually a neither variation. So now it's a little bit harder when you have, you're looking for, if I multiply the x and the y together and it's a constant value, that would be an inverse variation. If you divide the y and x and get a constant value, that would be a direct. So in this case, if you multiply these together every single time, you get a negative 24, which makes this an inverse variation. And this next one actually is if you divide the first ones, you get 2. You divide, you get 2, but the next one you get 8/3, and the next one you get 4. So it's not a direct. Multiplying, you don't get a constant value. So this is actually a neither situation. Now they're telling you that x and y vary inversely. So you're talking about x times y equals k. And they wanted you to first write an equation using the equivalent values. So x is 4, y is negative 6. That makes k negative 24. So the first part about this is actually writing an equation using our k value. So here's the first part. And then they want you to actually find y when x is negative 2. So y would be 12. So two parts to that question. One, write an equation based on your given values. And second, finding a value given an x. Next, and this is a big section on the test. There's going to be a lot of questions on the test in regards to graphing rational expressions. So now, the first one, we have a situation in which you're subtracting 3. So this is the horizontal asymptote at y equals negative 3. The value that makes the denominator 0 is x equals negative 2. There is no oblique asymptote because the degree of the top is not larger than the degree of the bottom, and there is no hole because nothing cancels. So now, graphing what we have, so x equals negative 2 is a vertical asymptote. Y equals negative 3 is a horizontal asymptote. And then you basically have to test a value to decide where you're going to graph this. So if I tested a value such as, whoops, I apologize for the graph. Hold on one second. I don't know how many of you noticed this, but x equals negative 2 should have been over here. So I apologize for that. So now I test a value like negative 1. I get 2. So it's graphed along the asymptotes. Test another value, and it would be graphed along the asymptotes in this area. So again, if a number is being added or subtracted, that changes the horizontal asymptote. All right, so next, the vertical asymptotes when the denominator is 0, so when x equals 1. Horizontal asymptote, because the degree of the top is smaller than the degree of the bottom, it's automatic, y equals 0. There's no oblique and nothing cancels, so there is no hole. Going back over here now, x equals 1 would be a vertical asymptote. Y equals 0 would be a horizontal asymptote. And then you're testing a value. It ends up going in this area along the asymptotes and in this one along the asymptotes. Graphing calculators could be of big assistance here. Next one, getting a little bit more complicated. The denominator does factor. That's important because when I'm trying to come up with my vertical asymptotes, I need the factored form to come up with the values that make the denominator 0. The degree of the top is smaller than the bottom. No oblique then, and no hole. So there's 2 vertical asymptotes, one at negative x equals negative 4, at 1 at x equals 3. Horizontal asymptote at y equals 0. So there's all my asymptotes in the picture. Next, I have to find out what area it is graphed in. It would be down testing a value, so pick any value that is smaller than -4. Pick any value in between. This actually zigzags. It goes through the point 0, 0. And then again, it tests a point that is larger than +3. All right, our first situation in which if I factor the top, it actually cancels. So that causes a hole when x is -7. What is left is not a fraction. So there is no vertical asymptote. There is no horizontal asymptote. There is no oblique asymptote. It is merely a line with a hole in it. So again, because this was no longer a fraction, it is no longer have asymptotes. It's merely a line, in this case, that has a hole in it. The next one, vertical asymptote when x equals -4. Now, the degree of the top and the degree of the bottom. The degree of the top is 1. The degree of the bottom is also 1. We're talking about the exponents. Okay, so anytime then you have that situation, the horizontal asymptote is always the coefficients. So 3 over 1. Nothing cancels, so there is no hole, and the degree of the top is not bigger than the bottom, so there's no oblique asymptote. X equals -4 is a vertical asymptote. Y equaling 3 is a horizontal asymptote. And then you just have to decide, using a calculator or picking a point, where this is going to be graphed at. It ends up being graphed here and here. Whoops, sorry. Nope, and that's it. Next one, obviously the most complicated of the group, and this is by far my favorite. Guarantee it's on the test. The top factors and the bottom factors. And something cancels. So that means there's a hole at the value that makes that 0, so x equals -4. And what's left is still a fraction. So now I got to go through all the work that with a fraction, or rational exponent, or rational expression. So now the vertical asymptote would be x equals 2. The degree of the top and the degree of the bottom are the same. And so there is no oblique asymptote. So graphing all those, x equals 2. Y equals 1. Graph. Again, graphing calculators can help you with this part. It is graphed in this area right here, up in the top left-hand corner, except at 1, 2, 3, -4, there's going to be a hole in the graph. And again, it is graphed in this area. So this is by far my favorite question because it has a little bit of everything. You have to factor, you have to cancel, and what's left is a fraction. And so therefore you have vertical asymptotes and horizontal asymptotes. Next one in the group. The top does not factor. So therefore vertical asymptote is 1. Nothing cancels, and the degree of the top is bigger than the bottom. So for the first time, we don't have a horizontal asymptote. We must have an oblique asymptote. In order to come up with the value or the equation for the oblique asymptote, we must do long division. So now, first term, they will get you x squared. Change the signs. Next term that would get me 3x would be, and change the signs. Even though it has a remainder, that remainder does not matter. So the oblique asymptote is y equals x plus 3. So when I go over to graph this, I have a vertical asymptote at x equals 1 and an oblique, or what's known as also a slant asymptote at y equals x plus 3. So those are my two asymptotes. Now I have to decide where it is going to be graphed at. It is going to be graphed in the lower right-hand corner, so up here and down here. Graphing calculators could be of assistance for you here, or just put in a point to decide where it's going to be graphed at. So you can do some XY charts and come up with the last value there. All right, next one. All right, it looks like we missed one off the review guide, so I will come back to that here in just a little bit. Next one, though, we're going to multiply straight across. So if we multiply straight across, we would get 24 x to the 6th, y to the 5th, over 60 x squared, y to the 8th. Reducing that, 24 over 60 reduces to 2/5. X to the 4th after I subtract x to the 6th over x to the 2nd, and y to the 3rd. Next one. Anytime I see a product, a multiplication, or a division for that matter, I need to think about factoring and canceling. So, and we have to worry about the divided by. So the top one factors to be x plus 5, x minus 2. The bottom one, don't forget about GCF. Then it's a times the reciprocal. Now, factoring cubics. X cubed plus 125 is the same as x cubed plus 5 cubed, which makes x plus 5, x squared minus 5x plus 25. Binomials can be canceled with other binomials. Binomials must have the same binomial in order to cancel. So x minus 2 can cancel with x minus 2. X plus 5 can cancel with x plus 5. This is a binomial 4, and 12 is a binomial. So I can actually cancel those to be 3. So the final answer is 3x over x squared minus 5x plus 25. You can put that in parentheses or not, but that is your final answer. Last one in this group. So I need to be able to factor each one of these. So 3x squared plus 7x minus 16. I have shown you a variety of ways to factor. Ultimately, you have to come up with a way that best suits you. 2x squared minus 18 also factors to be, you got to take out the GCF of a 2, and then it factors to be x minus 3 and x plus 3. Don't forget about GCF. And then the last one down here factors again, 3x minus 2 and x plus 6. The factoring is the hard part. The canceling should come easy. You're allowed to cancel anything that's in the top and the bottom. So x plus 3 cancel with x plus 3. 3x minus 2 cancel with 3x minus 2. 3 is the only thing left on the top. A 2 and an x plus 6 is the only thing left in the bottom. Adding gets a little bit more complicated. In order to add and subtract, you must have a common denominator. In order to have a common denominator, you have to come up with the least common denominator between 6x and 3y squared. So 6x y squared. Because they're binomials, you have to look at them individually. So the common denominator between 3 and 6 is 6. They both need an x then, and they both need a y squared. So I need to multiply this one over here by a y squared. I need to multiply the one on the right by a 2 and an x. And now for the finale. The denominator stays the same, and I merely add like terms in the numerator. Because there were no like terms, it merely stayed as 5y squared plus 4x. Next page. Common denominator. Now, because these are binomials, you consider them as being separate. So we need an x minus 2, and we need an x plus 5 in our common denominator. So the one on the left here needs to be multiplied by x plus 5 and distribute. The one on the right needs to be multiplied by x minus 2, and I distribute. Common mistake here. The denominators are now the same. When you start talking about adding like terms, you got to worry about the fact there's a minus sign there. So you are minusing both of those. So 4x minus 2x, 20 minus a negative 4. I will accept this answer. However, be careful. You always need to factor completely to make sure that you don't miss the fact that something might get canceled. Nothing in this one does get canceled, so therefore you are correct. Common denominator is a little bit harder to see in this one. X plus 6 and x minus 4. This one I factor out a 2. So when I'm trying to come up with what my common denominator would be, I need the factored form in order to come up with the common denominator. So I need a 2. I need an x plus 6. I need an x minus 4. So the monomial and the binomials. Well, the first one, the one on the left, only needs a 2, so I multiply the top by 2. The next one needs an x plus 6, so I multiply the top by an x plus 6. Now for the finale. The bottom stays the same, and I add the numerator. 10x plus 3x is 13x. Negative 14 plus 18 is a plus 4. Nothing cancels, nothing factors, so I am done. The next one looks hard, but it's not quite as hard as it looks. Think of the top as one question and the bottom as the second question, and then we're going to divide in the end. So if I just gave you 2 over x minus 1 plus 3 over x minus 4, you would come up with a common denominator, x minus 4 and x minus 1. The first one, the one on the left, needs to be multiplied by an x minus 4. The one on the right needs to get multiplied by an x minus 1. And so then I'm left with x minus 4, x minus 1 over 5x minus 9. So that is the answer to the, I apologize, I did make a small error. Hopefully some of you caught that as I was doing it. So I multiplied this by 3x minus 1. I should have got 3x minus 3. So I apologize for that. And now that is being divided by 6, x squared minus 5x plus 4. Since I'm dividing, I'm going to multiply by the reciprocal. X minus 4, x minus 1. Cancels, cancels. Final answer then, 5x minus 11 all over 6. Solving now. There's 2 types of solving questions that we worked on. One was solving a proportion. If you have a fraction equaling a fraction, that is a very specific style of solving. You're going to cross multiply 3x times x plus 2, which gets you 3x squared plus 6x. 1 times x plus 12. Because there's a quadratic, I'm going to get all the terms on the same side. This factors. So we have factors of 3x. So there's what the factoring would be. Setting the parentheses now equal to 0. I get x to be negative 3 and x to equal 4/3. If you have multiple fractions in the question, you need to multiply through by the common denominator. So the common denominator in the problem would be 3x. What that will allow us to do is to get rid of all the fractions. 3 gets canceled. I'm left with x times x plus 7. X's cancel. I'm left with negative 5 times 3. And again, the x cancels, and I'm left with 45. Getting all the terms on the same side so that it equals 0. This again is factorable. X plus 12 and x minus 5, setting the parentheses equal to 0, x to equal 5, and x to equal negative 12. Last one. I see something that is factorable, x minus 8 and x minus 6. That matters when I try to multiply through by the common denominator. I want the least common denominator. So I need that to be in factored form so that I can multiply each one of these by x plus 6 and x minus 6. I show my work, so I go ahead and multiply each one of those individually. And it should be x minus 8 and x plus 8. So I apologize right there. So x minus 8, x minus 6. All right, in the first fraction, the x minus 8s would cancel, leaving me with 14 times x minus 6. In the next one, the x minus 6s cancel, leaving me with, now be very careful, negative 5 times each one of those. So we're talking about negative 5x plus 40. And in the last one, everything cancels, leaving me with just 82. Getting everything on the same side. Oh, no, I'm sorry. It's just, so combining like terms, 9x minus 44 equals 82. 9x equals 126. X would equal 14. Anytime I do these questions, I know I didn't bring this up earlier, you always should check your answer to make sure it's not extraneous. None of the problems that I did previously were extraneous, and neither one was this one. Now, for the big finale, definitely one on your test like this. The middle one, factors, x plus 5 and x plus 3. So when I'm multiplying through by the common denominator of x plus 3 and x plus 5, I would multiply each one of these. All right, so now let the canceling begin. The x plus 5s cancel. I'm left with 2x times x plus 3. Everything cancels. Now, here's a trick. There's a minus sign. So I have to subtract all those. That is a very common mistake. It's minus x squared plus x plus 10. There's going to be a bunch of you that are probably not listening to this video that are going to get that question wrong because they're going to forget to subtract all of those. Get everything on the same side now. So I got 1x squared. 7x minus 3x would be a plus 4x. So these are gone. I'm going to subtract. I get minus 5. So everything equals 0. This does factor now. X plus 5, x minus 1. And x would equal negative 5, and x would equal positive 1, setting those equal to 0. Now, not so fast. You got to go back up to the original question to see if there's any problem, and x equaling negative 5 is an issue. It's an excluded value. You can't have that. If you end up having negative 5 as an answer, that causes a 0 in the denominator, and you cannot divide by 0. So please check your answer anytime you are solving. The only other topic that I want to make sure we talk about is there's word problems on the test that come off the 7-5 Day 2 worksheet, one in which you'll have a working together type question, one in which you would have a current or wind question where you're going against the wind and with the wind, and then one in which you are combining solutions. So that concludes our review for today. There was one problem that did not make it on here, so please make sure to talk to your teacher about that one. It's got 2 asymptotes. I can quickly kind of talk through it just a little bit. I'm going to write it out here. X cubed plus 2x squared minus 5x plus 1, I believe it is, over x squared minus 4. The bottom factors to be x minus 2 and x plus 2. So that gives us 2 vertical asymptotes at x equaling 2, x equaling negative 2. The degree of the top is larger than the bottom, so I would need to divide in order to come up with the oblique asymptote. So now I get, doing my division rather quickly here, I would get x cubed minus 4x. Change the signs in order to subtract. Pull down the next one. 2x squared minus 8. Change the signs. So even though this is your remainder, this would be your oblique asymptote. So oblique asymptote of y equals x plus 2. Don't forget the oblique asymptote. And just giving you a very rough picture, you'd have a vertical asymptote, an oblique asymptote, and then it would be graphed here, here, and here. So again, giving you a very, very rough sketch of the problem that I missed. If you have any questions, make sure you talk to myself or your teacher, and good luck on your test.